Hello, and welcome to my presentation of AI document processing. And in this presentation, we're going to discover about the proof of concept that I have implemented to understand how the Azure AI services could be used for the documents processing. My name is Michael, and a little bit about me. I'm a software developer. I'm a .NET developer. I'm an author of the video courses on Udemy, so you can use this QR code to find my video course. And I'm an electric guitar enthusiast. Sometimes I play a guitar when I have free time. So about this proof of concept and about the documents processing architecture. Basically, my proof of concept was inspired by an architecture from Microsoft Learn, and you can visit this link and find out about the architecture of a solution for the document processing. And you can find many more other architectures there, actually. So I highly recommend visiting this learnmicrosoft.com website. So you can see that in this architecture, the code, the services are basically organized into 3 steps. And the first step is extraction of the data from the documents. The second step is enrichment of the data. And the third step is analytics and visualizations. So basically, while I was implementing my proof of concept, I found out that there is a general pattern that is used for documents processing and like working with documents in general. This pattern is called ETL, which is an abbreviation for the extract, transform, and load. And basically, it says that there are 3 general steps that you do with any kind of documents in your applications. The first step is to extract the data from the document. The second step is to somehow modify or verify the data that you have extracted or somehow like transform it. And the third step is to load the data, or in this sense, to somehow use the data in your application. So we're going to look at the 3 kind of features that are using Microsoft AI services on Azure to deal with the documents. And for the extraction, we're going to use the form recognizer, which is an OCR service from Microsoft Azure, which is backed by AI models for the recognition of the patterns of the documents. By extracting this data, we're going to then verify the data, and the GPT model will help us to verify that the data we've gotten from the OCR is actually correct, and we will either modify the data ourselves, or the GPT model will help us to do this. And for this third step, we're going to use this data to search it, basically. We're going to look at the pattern that is called RAG, which is Retrieval-Augmented Generation. And well, basically, we're going to create a user query, a user request to find some kind of a data, and we're going to use the embeddings or vector search in the Azure Cosmos DB, and then the GPT model will generate the answer for us. So let's talk a little bit more about the form recognizer. As I've already mentioned, it's an AI-based computer vision. So you have several models, several types of models. There are pre-built models, and those are the models that already exist in this form recognizer. And you can use them for invoices, receipts, or identity documents. And we're going to use the identity model for the recognition of the passport data in particular. And well, there is an option to use your own custom trained model, which can be specific for some kind of documents that only you have to deal with. So basically, you have to handle all the training and all the setup for this model. But you can have this AI model for your specific for the patterns of your specific documents in the form recognizer. Well, about the pricing, there are two options how you can pay it. There is a pay-as-you-go option. So basically, you pay some particular money for 1,000 pages, and you can see that the cost for custom models are a bit more. And there is a commitment option, and in general, you are paying some kind of sum of in advance to get 20,000 pages already in your package, and for overage of the use of this package for each 1,000 pages, you're going to pay slightly less amount if you would choose an pay-as-you-go option. And you can see that for the custom model, the price is more than for the pre-built one. What are the alternatives of the form recognizer? Well, the main competitors of Azure are Amazon Textract and Google Document AI. And for the comparison of their abilities or features, basically they do the same stuff. They have pre-built models for the same kind of documents, and you can see that the only difference is basically that Amazon Textract is a little bit better with the handwriting, with handwritten documents. So there's not much different actually between those, but there are alternatives from other clouds as well. So, and the GPT model we're going to discuss as the next feature, but let's first demo and focus on the recognition of the document data. So this is the application I have developed, and basically, if you can remember, we have 3 steps, which is extract, transform, and load. And here we have 3 sections in this application. The first one is uploading the passport, and we're going to use OCR to get the data. Here is our passport list, and this is the list of the passports that were recognized by the OCR and saved to our database. And we can use the search option here to get the user query into some kind of AI model and to leverage the vector search here. So let's demo the first step. And before actually using it, I want to show you how it is implemented and how the solution uses form recognizer to get the data from the documents. So let's go to the code, and here I have my durable Azure function. So basically, we're going to get some kind of, in this this Azure function is triggered on the upload of the data into the storage account. So we are going to get some blob URI, which is the URI for the document we have uploaded. And then we're going to call the activity, which is called process with form recognizer. So let's go to the form recognizer activity. And here, basically, this is the activity for the recognition. We have, I'm getting the endpoint and the API key here. I'm introducing the document analysis client here. And the significant thing here is that we're preparing the requests with some kind of parameters here. And we're passing basically the document, which is the memory stream here. And we are saying that the model type we're going to use is the pre-built model, and it's the ID document. So then we are executing this operation, and we're getting some result. And let's go to this function that is basically uses the result of the request. So the main thing here is that in this result we have our particular document, and we're getting the fields of this document, and we're getting the list of the key value pairs. Basically, these key value pairs, they come from the AI model that we are using, and in the document ID model, we have a specific particular number of those keys, of those fields in this document. So say for each key here, we're going for each item here, we're going to get key value pair, something like name and the value of the name, something like document number, and we're going to get the value for the document number. Those keys, they come from this pre-built document ID model, and the model is trying to recognize those keys or those parameters, those values in the document. So here I use the logger, and I mark my logger with some like predefined pre-coming words. It's like I'm saying awesome field something, and I'm passing the key, and I'm extracting the content, the value for this key. So for the demo, we are expecting then in logs we're going to get a list of those key value pairs with coming with awesome field, blah blah blah. Right. So basically, then for each key, I have a switch here, and if it's first name, you can see that I'm populating some entity with first name, and yada yada yada. So one of the parameters here is specifically interesting for us. It's called machine readable zone. So if you can remember any passport, there's at the bottom there's like kind of the data in the form of arrows, like there's at the bottom of your passport, and basically this is the values we're going to verify that our data from other parts of the document is recognized correctly. So machine readable zone is also parsed here. So this is the code that we're going to look at, and this is our Azure function. And let's go to the Azure portal here, and I have my Azure function here, and I have a log stream of this Azure function, and we are expecting to see some data here when we parse the document. So let's select some kind of a document, and here I have the passports that are basically samples of the passports. And let's observe one of them. So here I have some kind of passport. This I found just on the internet, some passport that was an example, right? And you can see that there's at the bottom there are some values that are in the machine readable zone, and this is the value that we're going to verify against. So just for you to know what I was talking about. So let's upload this passport. I've selected the file, and let's click upload. And there's a chance that the application will fail because I'm using the free tiers of everything, and I have not implemented the option for the poly and try again policies. I did not implement it, so let's upload it one more time and hope that this time everything will work. And nope. and says that passport uploaded successfully. So the passport was uploaded into the storage account, and now the uh, Azure function should spin up and take this passport and do all the processing. So we're waiting for some kind of response in the log stream. And nothing changed, right? What if I go to the log stream again? Okay. And let's say that I want to upload the file one more time. And I have uploaded it. We're getting some results here. Something is going on. And we've got the results here in the logs, and we can see that some awesome field country region was logged here with the value D and the date of birth of the person, but the date of expiration is here, and other fields, right? And you can see that there is a machine readable zone here, and the machine readable zone values here with those arrows that we've seen from the bottom of the passport. This is what we're going to use for the verification. So, well, here in our application, we should reload the page, and we will see the passport that we have parsed from the OCR. And it may take time because of the cold start. So yeah, it should take some time. So let's not lose our time. Yeah, there it is. So we've used the OCR 2 times. So there are 2 passports here uploaded. So yeah, everything worked. So let's go to our presentation and talk about the second step. Well, basically, we've got the values from the OCR, and we have our passport in the list of our passports. So now we should check and verify the data. So in this demo, we're going to use the GPT model from Azure OpenAI Services. So basically, in those Azure OpenAI, among those OpenAI models, you can find models from OpenAI like GPT, like how you call it, Dolly, or other models. And basically, there is a number of them. They are already there. They're pre-built and ready to use. But there is a difference between the Azure OpenAI models and the OpenAI models that you get from OpenAI. So there is the benefit of the customization of those models. You can tune them, and you can have some kind of specific parameters of those models, or pre-coming requests. So you can define what is going to be in the request to those models in advance. They are easy to integrate because they are within the Azure infrastructure and within the Azure solution. And with those Azure OpenAI models, you get security and the compliance. So you have the enterprise grade security, and those models are compliant with requirements of the GDPR, HIPAA, or others. So about the pricing, there are different models, but I took 3 of them. 2 of them we're going to use, which are GPT and the text embedding. And there is a DALL-E model, which is the scope of this demo. So basically, you can see that the way you pay for them for the GPT model, it's the input and the output, and you get the price for you pay the price per 1,000 of tokens for the input and the output. And for the text embedding, which we are going to use for vector search, you can see that there's a pretty small price per 1,000 tokens. For the models like DALL-E, you have basically not only price per amount of images you're generating, but also the price changes based on the resolution of those images. And as for the alternative, you have other options on other clouds like AWS and Google Cloud. Basically, I can say that Google Cloud varies only because they can give you a more logically reasoned steps, although those parameters change all the time because the models evolve. So probably there's not much difference between those models on various clouds. About AWS, it's a little bit focused on ethical responses. So it's a little bit more sensitive for the ethics of the AI. The feature I'm going to demo you now is a kind of verification feature. So we're going to use the GPT model to verify the data we've gotten from the form recognizer. And basically, you can see that at the screen we have the step that we already passed. We've gotten the data from the form recognizer saved into the storage account into the Azure table. And now our human has to verify that the data from the OCR is correct. And we can use it like checking. The human can check itself, but we can leverage the GPT model and ask the GPT model, here's our passport data that we've gotten. And here's the machine readable zone from the bottom of the passport. So please compare those two and tell me if those are correct. If not, suggest your value from the machine readable zone that you think that is relevant, that is actually should be there. Or if you cannot verify, then please tell me that you cannot verify this data. So I would be specifically focused on this data to check. So we are sending the passport data, and basically we're getting the response if the data is correct or if it's incorrect or the data can be verified. And then the human verifies that everything works, that everything was checked, and it's some kind of a double check by the human and by the GPT model, and the result is saved for the Cosmos into the Cosmos DB for the usage of the data. Here we have our passport with this Erica person, and you can see that here inside of the passport we have the property names, which is basically the first name, the last name, the date of birth, and other. And we have some OCR value here that is we have actually gotten from the OCR. And there's a column of values to save. So these are the values we're going to save into the database. And apart from checking, I'm going to ask the GPT model to standardize all the dates we're getting here from the OCR. The feature here is that in various passports, the dates are the form of the dates can vary significantly. So in some cultures, it's the data in this, I don't know how to say, in this format. in other dates, the formats are incredibly different, even like written in letters in other languages. So we're going to cover the standardization of the dates as well by the GPT model. So we have the machine readable zone here. That is, that is basically the data from the bottom of the passport, and you can see that everything, well, not everything, but most of the values are encoded here, like the name of the last name of the person, like the document number here. You can find it here, and there are some other kind of dates or values there, and etc. So we're going to click this button and send the data for the verification. But before we're going to do this, let's look at the code and how actually this works. So I have a controller here with my action method. And here I have the OpenAI service injected into my controller. Although it's just a demo, and I could have just written the code here inside of the action controller, I decided to use the dependency injection pattern here and to encapsulate the code for the GPT, because look at the amount of the words or data here to make a request. So it's a kind of huge method here, and I didn't want it to be in the controller. So yeah, if you are going to use the GPT requests in your solution, be prepared that you have to store some those kind of requests somewhere. So what is our request here? What is the user message that we're going to send? So we're saying that there's a task to parse machine readable zone of the passport, and we should compare the machine readable zone values with other data that is provided. And we're expecting to get some kind of a JSON response that is in a particular format. Sorry. So we're saying that we are expecting to parse the machine readable zone in a specific format and to compare specific fields. We're saying that we're expecting to validate data in some specific way. And we're saying that we have the dates and they're come in the non-standard formats like this and others. And we're saying just that we expect the end dates in some specific formats, and it should be even checked for USA or European countries kind of format where month and days they come in different places. So basically, this is the request we're sending to the GPT model, and we're saying that the passport data you should verify is this, and we're serializing the passport data, and basically here will go the values of our passport. And we've gotten here the kind of parameters for GPT models like temperature, and it's going to be to influence some kind of the response that we're going to get from the GPT, right? And another particularly interesting thing here is that we said that we're expecting the response in some particular JSON format, because, well, you know, if you ever used ChatGPT, it generates the responses randomly. It's just simply the random text generation machine, so it just spits out different results on the same request every time. But we want to use the response in our application. So we are expecting all the time, all the responses we are expecting in a specific format, because we should use it somehow in our application to, for example, for the front end, to understand which data is correct, which isn't correct, what kind of data we should display, right? So basically here in this parameter, in this options that we're going to send, we're saying that there is a JSON schema that we're expecting in particular, and it's going to be a list of objects, and each object should have the property name of the passport that we're expecting that is being verified. There should be a suggested value, and we're expecting here either the value that was there originally and it's correct, or we are expecting the value that GPT suggests that we should use from machine readable zone, or we expect the value that was already there, but GPT didn't manage to verify it somehow. And to understand what is the state of the value of the verification, we have here the property which is called is valid, and the type of the property is Boolean or null. So it's a nullable Boolean, and we expect true if the value was actually correct, and the value is correct. If it's incorrect, we expect false here. And if there is no value in the machine readable zone, we expect the value of is valid property to be null. So we understand that the value couldn't be verified. So let's go to our demo here, and let's open the developer tools, and we have the network tab here, and let's modify the name of our person. Let's say that we have the value of name Bob here from our OCR, for example, right? And we're expecting here, if the value is wrong, we're expecting this this cell in the table to be highlighted as red. And for other values that could not be verified, for example, like issuing authorities, here we have now this value in this machine readable zone string. So we're expecting this value to be highlighted as orange because we couldn't, as yellow or orange because we couldn't verify it. So let's press the verify against machine readable zone button here. And we should get some data at some time. So probably there is some error because of the cold start, and nothing works from the first time. So let's do this again. And it didn't work out the second time either. Let's try the third time. And we've got some response. And let's go to our response, and let's see that the response for our request is the property name, first name, and the suggested value is Erika, and the value was invalid. So you can see here that GPT model suggested the new value. It highlighted that the background of the cell said that this is actually an invalid value. So the next value that is interesting for us is the date of issue, and basically it transformed the format and highlighted that this date of issue value cannot be checked. So let's find this date of issue here, and the date of issue, you can see that is valid, value is null. Well, sometimes the GPT model is not perfect, right? So we get incorrect incorrect results here. So it thought for some reason that here we do not have the Deutsch value, so it decided for some reason that Deutsch is incorrect here. So let's put it manually. And for the document type, for some reason, it also considered this value to be incorrect. So probably for specific formats, so something should be like that, right? So you can see that some of the values were modified by the GPT model, and it's actually quite unstable, I must say. So I've tried to modify the request, which I was showing you, this one. I've tried to modify and specify in the detail what do I want from the GPT model. I have improved it a lot, but you can see that some of the cases are unpredictable, and so this is the case, right? So let's save those changes, and I want to show you the case for the dates I was talking about. So here we had, I guess this is the sample passport for the British person. So you have here the date of issue written in several languages, and this is the data format that occurs in the passport. So imagine like going through all the possible passports and creating some kind of a parsing code that parses all of the kind of passports into specific values, right? It's just a lot of work. So we're basically saying to GPT model that we want to standardize those dates, and the GPT model works quite well with standardizing them. So it's getting the value in some text format and presents us the date that is in the expected specific format, right? So some of the features are, some of the ways to use it is quite beneficial. So the third feature and the last part of the demo is using this data, and we're going to discover the RAG pattern, which is Retrieval-Augmented Generation. And I want to give you some kind of a presentation of what is going on there, because the pattern is quite complex. So we have our passport data, and we want to allow our user to search the data. So let's say our user wants to get the name of the person from Germany, and the user sends the request to the backend, to the .NET application, and the .NET application, it sends the request to the embedding model, and the embedding model in response gives us a number of floats. And this number of floats is called vector, which is kind of a digital representation of the user query. And with this vector model, the backend is going to send it to the Azure Cosmos DB. And Azure Cosmos DB is going to use the similarity match, and it's going to compare the request of the user in the form of vector to the vectorized data inside of the Cosmos DB. It's going to find the similar kind of data. So this is the relevance search. It's not the direct comparison search. So then the Cosmos DB is going to send back the passport data that it's found based on the relative search to the backend. But instead of sending it back to the user, we're going to send the user request in its original form, like name of the person from Germany, plus the passport data. So we're going to ask the GPT model to get the specific details and to generate the response in the kind of AI model would generate based on the user request and based on the data that was found in the Azure Cosmos DB. And only then we're going to send back to user the AI generated response. So before demonstrating this this feature, let's go to the main part of this pattern as far as like for me, from my perspective, the most important part in this pattern is Azure Cosmos DB and the way the Azure Cosmos DB handles this relative search. So the embedding 3 model gives us vectors based on the data we send. And basically, the Azure Cosmos DB stores the data of the passports. So you can see that those are the passports we have in the list. There's 3 of them, but one of them we doubled. Like we've gotten the double response from the OCR, right? But we've saved only one of them. So you can observe that we have the passport data here. And apart from the passport data, we have the property that is called vectors, and it's just a huge list of some kind of floats, which is actually, this is the vector that we've gotten from the embedding model. So first, before we're on the backend, before I save the data into the Azure Cosmos DB, I also send this data to the embedding model, and I say, like, give me the vectors for this data. I get the vectors, and I save the passport data plus the vectors into the Azure Cosmos DB. And then we are going to leverage the vector distance feature, the vector distance search in the Azure Cosmos DB. And to use it, you should, when you are creating the Azure Cosmos DB data container, you should turn on the feature of the vector search. So you go to the features and you turn on the vector search for API here. And right now it's on, but by default it is off. The very important thing here is that you cannot turn on this feature for the data that already exists in the database. So in order to use it, you should first turn on the feature, and only then you should create the container inside of the Azure Cosmos DB. So you cannot use it in the case when you already have the data in your database, and after this you turn on this vector search feature, it would simply not work. So be careful about this, and I guess you should somehow migrate your data if you already have your data and you want to use this similarity vector search. So let's go to the backend and let's observe the code that is using this feature. So I have the search controller here. Here's our search method, and we're going to get the user query here. And the first step is we're going to send it to the embedding model, and we're going to get this embedding vector. Then we're going to get a single passport from the Azure Cosmos DB based on the vector representation of the user query. Then we're going to get some documents, and we will send it to the GPT model. We're going to send the user query plus the serialized document that we've gotten from the search from the Azure Cosmos DB. Then we're going to send the result to the user. So basically, there is nothing interesting in the getting the embeddings. It's just requests to the model to get the result from the user query, right? So let's go to the part where we search the data based on the vector. So we have the vectors parameter here. We have the similarity score, which is basically the some kind of a threshold on the similarity of the results. So we do not want all the results. We want to filter them. Sorry. So let's observe the query that we're sending to the Azure Cosmos DB. Well, here we're selecting some kind of specific fields of our passport, and you can see that one of the things that we're selecting is actually the result of the function that is called vector distance, and we're passing the property of the data inside of the database, which is called vectors. The property that was saved in the Azure Cosmos DB in the passport, right, with the vectors. And we're sending here the vectors parameter, which is actually the vectors from actually the user request in the form of vector. And we're selecting it with the name of similarity score. And here we have the condition that we want the passports with the similarity scores above this input parameter threshold, which is 10 here. And well, we're sending this request, and we're executing the request. We're getting the response, and we're getting some kind of a list of documents here. And then, as I've said, we're passing it to our GPT model plus user request. So this is the way it works. And another important thing for you to understand what's the benefit of this feature. So let's go to the data back, and let's go to the passports, and the passport we have recognized here. So we're going to search for the name of the person from Germany. And you can see that in the data here, there is nothing that is related to the word Germany, although it has some kind of parameters like nationality Deutsch, and place of birth is Berlin. And basically, those are similar values that you would expect to be similar with the word Germany, right? So there's no exact value, and the user is going to request the name of the person from Germany. So let's do the query, the name of a person from Germany, and let's send the search request. And actually, I expect this request to fail because of the reason, because of the thing I'm going to tell you after it fails. Well, first of all, it could fail because of the cold start, but the reason I expect is based on the way the GPT model behaves, or yeah. So we've got response to saying basically, I'm sorry, but I can only provide information from passports data that has been provided to me. If you have specific passport data you'd like me to look at, please share it, and I'll do my best to assist you. So basically, we've got the response from the GPT model, but it says that we did not provide any data. So the solution that is actually hosted on Azure at the moment was implemented by me, and it worked perfectly well. And after some period of time before I wanted to create this video, the feature stopped to work. So basically, the situation now is that this instance that is hosted on Azure, it perfectly fine finds the passport in the Azure Cosmos DB. It gets the passport. It sends the user query with the passport data to the GPT model. But in response, we're getting the response that there was no passport data provided to the GPT model. So I started the local instance here, and I wanted to debug the way it works. So let's update this page to get our new passports. So we can see that this is localhost 3000 that is running locally, and we have the backend here also running locally. So I wanted to go to the search controller and to press the breakpoint here to understand what's happening. Like, did I really miss the data? Was the data provided or something? So let's debug it together right now, and I'll show you the problem with this solution. So let's send the name of a person from Germany request. So sorry for the Germans. Should write the name of the country starting with big letter. So we've sent the request to our backend. So here we have our action method, and here in the parameter user query, you have the parameter name of a person from Germany, right? So we've gotten our request, and we're getting the embeddings from the embedding model. So let's get those, and you can see that embedding vector data here. This is the vector representation of our user query. Everything works. So this is going to send the request to the Azure Cosmos DB, and let's send it. The retrieved documents list here is the passport that we expect. There is nothing says that this is passport from Germany. So we found this passport based on similarity. So this works. We're getting rid of the vectors here because we don't want to send the vectors into GPT model. And we're sending the request to the GPT model. Let's go inside of this request. So here we're just generating the client to work with, and here we are generating the messages we're going to send. So I have corrected the issue here. Actually, it wasn't the issue; it was working perfectly well. So within the messages for the GPT model, we have the system chat message here. Basically, this is the string, and if we will go above, it's just a general request to the GPT model that your intelligent assistant for the passport documents office and blah, 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 blah. You have to give us the data, and if you have no data, you say you don't know. So this is just a general formal request. This part is the system chat message. And before the implementation was like this documents. So it wasn't the documents wasn't in the user chat message. It was in the system chat message, and the system worked perfectly well. But after some period of time, it stopped work, and it started to say me that no documents were provided. Please provide the document. So the thing I did is I changed where this documents parameter is located. I just added the documents to the user chat message. So this is the user prompt name of a person from Germany, and I say that this is the passport data and send the passport data right here. And just basically we're sending this request to the GPT model. So for some reason, this solution stopped working, so I had to change the place where I send the documents. So kind of an unstable part of using the GPT. We're going to get the exception because the operation was canceled from the front end because we were basically holding on the debug point for too many long. So let's send our request once again. We're not going to debug everything, and let's look at the response. So you can see that this time it worked, and we've got the response from the GPT model. And the response says that passport holder's full name is Erika Masterman, and expected passport details, it just provides us with other details from passport, right? And you can see, so the response is modified. So it says basically nationality, and the nationality here Deutsch, and basically GPT generated that it's considered to be German. And yeah, there was some data was modified that Sax here is written in the full format. So in the original passport data, I guess it was something like just F letter. Let's go to our Azure Cosmos DB. So yeah, you can see that Sax value here is F. So GPT generated the full, the response is full, right? Female, and it basically says, if you need further assistance or verification, please let me know. So we've used two models, one model for the search and the second model for the generation of the response. So basically, this is it. This is the end of my presentation, right? I just wanted to share you the ways of you can use the Azure AI services for your document processing solution. Well, if you have any questions, you can find me on my LinkedIn account or my YouTube channel, or on Instagram. So yes, thank you for your time, and I hope to present a full video lesson on how to implement this solution on Udemy soon. So probably there will be a link in the description to the full video course on how to implement this solution. Thank you for your time.